All right, today we're going to talk about something that's maybe the most important part of modern AI, but you never actually see it. It's called the context window. Think of it as the AI's memory, and it's basically the thing that determines how smart an AI can actually be.
So just imagine this for a second. What if you're talking to a total genius, a brilliant expert, but they forget the beginning of your sentence by the time you get to the end? It'd be completely maddening, right? Well, for a long time, that was pretty much the core problem with AI. I mean, how are you supposed to reason or plan or just have a normal conversation if you can't even remember what was just said? This is exactly the problem the context window was designed to fix.
All right, so let's get right into it. The easiest way to think about the context window is as the AI's working memory. And I don't mean like some old dusty library of facts. No, this is the active, buzzing, right now workspace where all the real thinking happens.
And that phrase working memory is absolutely crucial, because this stuff isn't permanent. AIs don't naturally remember anything from one chat to the next. They're kind of like a blank slate every single time. So for any given task, all the info it needs has to get loaded into this temporary workspace. And the way we measure the size of that workspace is in tokens, which you can just think of as little pieces of words.
So what's actually in this window? Well, basically everything. It's the question you just asked it, the whole conversation history leading up to that point, some high-level system instructions that tell it how to act, and of course any documents or files you've given it. You have to understand, for that one single moment, this window is the AI's entire universe. If a piece of information isn't in there, as far as the AI is concerned, it simply doesn't exist.
And that brings us to the next chapter of our story, the Great Expansion. Because, for this technology to go from a neat toy to a genuinely useful tool, that universe, well, it had to get a lot bigger. And what happened next was this insane growth spurt that really does feel a lot like Moore's Law.
I mean, just take a look at this timeline. Back in 2018, GPT-1 could handle, maybe a page of text? A couple years later, GPT-3 is up to a few pages. And then the floodgates just burst open. You get GPT-4, Claude 3, and now Google's Gemini 1.5 Pro, which can process over 2 million tokens at once. This isn't just a gradual increase, people. This is a full-on revolution.
Let that sink in. A 1,000 times increase in capacity in just 6 years. To give you a sense of scale, that's like going from being able to remember a single paragraph to being able to remember the entire Lord of the Rings trilogy. And yeah, I'm talking about the appendices too.
And with that kind of scale, you unlock entirely new powers. We've moved way beyond just asking an AI for a simple fact. Now, you can have it analyze an entire book in one go, or debug a massive software codebase. You can feed it the transcript of an hour-long video and ask it to find the key moments. This is a complete game changer in what we can ask these things to do.
But, and you knew there was a but coming, right? Here's where the story takes a fascinating turn. Because with all this incredible power comes a hidden cost. This is what we're calling the paradox of scale, where just getting bigger and bigger actually creates a whole new set of really complex, kind of counterintuitive problems.
Okay, so the technical reason for this, and stick with me here, is something called the self-attention mechanism. It's the engine at the core of the AI. And the main thing you need to know about it is that it has what's called quadratic complexity. So, in plain English, if you double the amount of information you give the AI, it doesn't just have to do double the work. It has to do 4 times the work. That is just a brutal scaling problem.
And that quadratic workload has some really serious real-world consequences. First, operational costs just skyrocket for every single query. Second, response times get slower and slower and slower, which makes any kind of real-time interaction almost impossible. And third, it creates this absolutely insatiable hunger for the most powerful, expensive, and, frankly, scarce computer chips on the planet.
But the issues aren't just about money and speed. There's another, more subtle flaw in how these huge models actually think. It turns out, even if you can afford to give an AI a massive amount of information, it can still really struggle to find that one crucial detail it needs. It's the classic needle in a haystack problem, but for AI.
And some really cool research has shown us exactly why this happens. This chart here shows what they call the lost in the middle effect. It turns out AIs are actually great at remembering stuff you put at the very beginning of a long document, and they're also great at remembering things from the very end. But all that information you bury right in the middle, whoosh, the accuracy just plummets. The signal gets lost in the noise, and that crucial fact is forgotten even though it's technically sitting right there in its memory.
So, faced with these massive challenges, these runaway costs and a memory that's surprisingly leaky, the entire industry kicked off a brand new race. The goal wasn't just about making the memory bigger anymore, it was about making it smarter, faster, and a whole lot more reliable.
And pretty quickly, two main paths forward started to emerge. The first is what you might call the better brain approach, basically re-engineering the AI's core engine from the ground up to be way more efficient. The second path is smarter access. And the idea here is, instead of trying to cram everything into the AI's head at once, you just give it the ability to look up information when it needs it, kind of like an open book exam.
Let's dig into that smarter access approach for a sec. It's got a fancy name, Retrieval Augmented Generation, or RAG for short, but it's actually a pretty simple and brilliant three-step dance. First, the system retrieves relevant facts from some external database. Second, it augments your original question by adding those facts right into the prompt. And finally, the AI generates its answer using that fresh, targeted information it was just handed.
And this table really shows the critical trade-off here. A massive context window is awesome if you need to synthesize one single giant document. But RAG is basically unbeatable when you need real-time, up-to-the-minute information. Think today's news. Or, and this is a big one, when you need to verify where the heck the answer came from, RAG can actually cite its sources, which, is a total game changer for building trust.
Now, that better brain path is just as exciting. This has led to some incredible innovations, like a technique called FlashAttention. What's so clever about it is that instead of trying to change the fundamental math, it completely reorganizes how the calculations are done to perfectly match the strengths of the computer hardware itself. It's a really deep, hardware-aware optimization that just makes the whole process dramatically faster without losing any quality.
So all of this innovation, right? The smarter access with RAG, the better brains with FlashAttention, it's all pushing us toward a truly mind-bending goal. The ultimate quest, to build an AI with a truly unlimited memory. The infinite frontier.
And researchers are already hard at work figuring out how to get there. One really cool idea is something called compressive memory. It would work kind of like our own brains, where we don't remember every single word of a past conversation, but we remember the gist of it. Another idea is self-retrieval, where you train the AI to intelligently decide which of its own past memories are actually the most important ones to keep and pull forward from this infinite stream of data.
And this all leads us to a pretty clear conclusion. The future isn't about one of these solutions winning. It's going to be a hybrid approach. It's this beautiful combination where you use RAG for super fast, real-time lookups from the outside world, you use a large context window for deep thinking and synthesis on that information, and the whole thing is powered by these new, hyper-efficient architectures.
So, why does any of this really matter? Why should you care? Well, because solving this memory problem unlocks a future that honestly feels like it's straight out of science fiction. Just imagine an AI assistant that has a perfect, lifelong memory of every single interaction you've ever had with it. An assistant that can learn and grow right alongside you for your entire life. Ultimately, this entire quest, this whole journey, it all comes down to a really simple but powerful idea. Expanding the context horizon, it's not just some technical benchmark. In essence, it is the expansion of the AI's capacity for genuine understanding.
Which leaves us with one last big question to think about. If we actually pull this off, if we succeed in giving an AI a truly limitless memory, a perfect recall of all information, where does its raw knowledge end and where does its real understanding begin?